All right. All right. Welcome everybody to Tuesday. We are very close to the end. We just need to get over this fraction mountain. Relatively speaking, it might be one of the harder things in the course, but nothing we can't handle. Same as always, can I just get confirmation that you can see and hear me? All right. Okay, we are talking about fractions. How has your fraction journey gone so far?
It's gone well, but it seems like quite a bit of information. It's just a new way of representing it, writing it all out like that.
Yeah, this is a bigger one for sure. Um, we have to let go of how we would do it and think more how would you introduce it for the very first time in terms of arithmetic. The fraction concept, I've actually just done it with my 6-year-old 20 minutes ago. Uh, Starting with a half, they already have an intuition, breaking it up, and what the numerator and denominator tells me. So it's not a lot of work there, visualizing it. But when you get to arithmetic and putting and comparing, then she started to not see it as easily, and rightly so. When you want to compare fractions, you want to make those denominators the same. Otherwise, it's not reliable, and you can't do it with confidence every time. And how we do one way of doing that, of making them comparable, making the denominators the same, is just this two-way splitting of our rectangle. If I split it vertically into four pieces representing 3/4, and I compare that to, I don't know if I did it here. I don't know what I did in the book. Let me just do it again. So let's suppose I'm comparing 3/4 to 2/3, the classic one. I am going to, I'll do it fast because it is in the book, not bothering with the straight line tool. If I start, but with columns, which is my choice, it doesn't really matter, I can then, by basically understanding what the fraction representation is telling me, highlight three or select three of the four pieces. So I would have that section over there. But if I were to look at 2/3, the trick is that I don't want to start columns as well. Then they're going to be difficult to compare. So I'll go the other way in rows because I'm eventually going to compare them. If it was on its own, it doesn't matter how you split them up as long as they're equal parts. Let's go blue, and then we have our selection according to what the fraction tells me. If I now want to make them comparable, now we know that we want to have a common denominator. Little Timmy doesn't even barely remembers the word denominator. It's so intimidating. I don't want to really make him think of that. I want to, by way of diagrams, trick him into making a common denominator. And how we can do that is we are going to multiply both the numerator and denominator of the first fraction by the other denominator 3. And graphically, if I can call it that, what that means is splitting it into 3 rows. Now the original 4 columns now become 12. The original 3 columns that were pink now become 9. I've multiplied by 3. Now I'm not going to tell him that. He's going to do it by diagram. So that shows that this is then equivalent to 9/12. And on the other side, I'm going to use the other denominator 4 and just split it in the other way so that they're more comparable that way. What I've done is I've multiplied by a common factor 4, showing that this is equivalent to the fraction 8/12. And then I can compare them very easily. So by way of diagrams, I can build a better number sense for fractions instead of just focusing on the mechanical shortcuts to get the job done. Building that fraction sense makes things much easier when I look at word problems and fraction concepts in between words and language. Number sense is what I need. So we are sort of trying to essentially accomplish the same things as what we know it should be when it comes to arithmetic, but by way of diagrams. Okay, let's just read the text here. I understand how to represent them, addition, subtraction, but the multiplication, division, yeah, that's not as obvious. I don't know how to represent divisions. Okay, so the main part of this is the four operations, right? Now, subtraction and addition are very similar. And when I think of addition, I'm simply thinking of the put stuff together concept. And there might be some cleanup to really group things together and simplify, see what do I really have. But the concept of just throwing stuff together, not that complicated. But I can definitely do one if we need to. Maybe we should do a small one. Why not? Let's say we have half plus 3/4. So then I'm going to represent each one, and I'm going to see them all because they are separate amounts, if you will, that I am merging together. Now each one of them is in reference to a whole, so it's a half of a whole with or together with, whoops, that's a G, together with 3/4 of a standard whole rectangle. So now, again, I'm not doing this the shortcut way. This is the intuitive number sense starting point. So I decide, let's go half in columns. Why not? Color it in. There it is. It's my first fraction I start with. I don't want to do columns again. Now I could because it's a 2 and a 4, but in general it might not work that well. So I'm going to go my other direction, which would be rows, and select what the numerator tells me to. So we'll get to the multiplication and division soon enough. I just don't want to jump over this. All right, so in order to merge these effectively, they need to be comparable, and that's where the diagram common denominator, whoops, not blue, common denominator trick comes in. A quick way to get them comparable is, ooh, that is wobbly. Maybe I should use my straight line tool. I like the challenge though. Yeah, they're not bad. Use the opposite denominator to tell me how to split the diagram. Now this is comparable. Not that I need to write this down, but I'll just show the similarity. Uh, this is now 1, 2. Actually, for the intuitive way, maybe I shouldn't. I'm just going to write here 4 pink pieces. Right, we're trying to avoid the shortcut putting it over 8, merging them, calculating. This is like the number line model, the very basic elementary approach. Over here I have 1, 2, 3, 4, 5, 6 of the same, just blue little pieces. And again, of course, this is not the only way to do it. I'm just uh, doing it in a way that makes the most sense to me and staying on that intuitive left side. So then when I put them together, we have 10 little pieces. Now it takes, obviously, 1, 2, 3, 4, 5, 6, 7, 8 pieces to fill one whole rectangle, and we have 10. So we have one whole and another 2/8 of a rectangle. And in that way, I am on purpose avoiding the shortcut. I'll put it in brackets, not part of this answer. Maybe over 8 you put it, and then that's 4 plus 6, 10 over 8. See here where I never write an improper fraction. Improper fractions are way more efficient for calculation purposes, but that's not my goal here. My goal is to teach this for the first time. I'm not going to do it this top way. This doesn't exist to me, to be honest. I'm doing it with diagrams and building a sense of what these fractions are. So if the question asks, use a diagram or a parts of a whole concept to explain something plus something else, then there is no place for this top version, because that is not what we're asking, and anyone can do that. But we are thinking of the teaching side, and that first step, the correct first step. If you shortcut it to that bracket top efficient line, there is no understanding. And then we are surprised, like, oh, why are kids so afraid of fractions? Because we never gave them a chance to understand it. Is it a surprise? Not at all. It's up to us. Regardless, the putting together concept is quite intuitive. We are essentially, with all of these strategies, we are essentially doing one thing. We are converting the fraction problem to an integer problem that we already know how to do, and then we transfer it back to the fractions. We don't necessarily know how to handle fraction arithmetic. By way of the diagrams, we convert it to an integer arithmetic, which we can very easily do, and then we convert it back. That's going to be the same for all of them. But of course, depending on the operation, different things are required. Let's suppose we take 3/4 minus, should we maybe take 1 3/4? Minus, I'm just going to change it to make it easier. No, well, not easier. 1 1/3 minus 3/4. Let's do that. Because I'm trying to dip into this one whole. So now the concept here is a takeaway concept. Takeaway. Now notice in the case of, I'll just squeeze it in somewhere. This is closer to the chip model now, because I have pieces that I can see and that I have to remove or add and so on. So in the chip model, if I had very basic 5 minus 3 chip model, What do I do? Here, it's something that we never think about, but it makes such a difference. If as a student learning this for the first time, you're on the edge of understanding, makes a huge difference to set up subtraction correctly. This 3, the first number is what I have. That 3, I never have that. It's more an instruction of what to do than it is a physical chips. I don't put 5 chips down and then 3 chips somewhere else. That's never going to happen. That is going to look to little Timmy as if I have 8 chips, and that's not at all what's happening. I have 5 chips. Now there's no negative numbers here, so I'm not going to worry about coloring them. This is all positive numbers. The instructions then say to remove 3 of them. Remove. And therefore, I have left 2 chips. 3 chips isn't an extra thing as it is in addition. The instructions are very different. And when I go to larger number arithmetic subtraction, it could benefit kids a lot to focus on the instruction of what I'm supposed to do rather than trying to make this the same as addition. It's not the same. It's a different set of instructions. So taking that approach here, I set up what I have. Let's draw that. I have a whole 1. There it is. And a little portion of another 1. So for that, I need to split this into 3 equal parts. There we go. That's what I have. I have 1 and a third. Now the instructions are saying take away 3/4 of a whole. Of a whole. So what I'm taking away is in reference to a whole sort of standard default rectangle. Okay. I have a hair in my mouth. Hold on. That's nice. I don't understand 3/4, if you will, because I've been working in thirds. So I'm going to have to split it the other way to make sense of what that even is. Now, I am going to, well, let's suppose I don't know. I don't really want to dip into this whole solid pink rectangle. If I'm trying to understand the instructions are to take away 3/4, I'm going to say, of a whole rectangle. Looking at the right rectangle and ignoring the pink, I have a whole rectangle that I can look at. The instructions, to make sense of the instructions, I don't care about the pink right now. I'm caring about the amount I need to take away. So 3/4 of a whole, in this case, they are rows. It means take 3 of 4 rows of a whole rectangle. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9. That means I need to remove 9 pieces. But I need to remove them from the pink. Sure. I need to remove, so take away 9 of the pink pieces. Now that I understand how many I need to take away, the instructions are saying take them of the pink because that's what I have. I don't really have the other ones. Now I see in this second rectangle, I only have 4. I need to take away 9. So I'm going to have to dip into the first rectangle as well, which means I should split it up the same way. In addition, I'm never going to break up an existing full rectangle, but in subtraction, I might have to. So now I see, okay, I need to take away. So let's do that in black. Remove 9. 1. Oh, did I do that right? Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have left 1, 2, 3, 4, 5, 6, 7. I have 7 pink pieces left. So because I am not relying on the shortest, most efficient way, this is going to get wordy and detailed and long. But it's very beneficial to do that, to build that sense. What is happening here? You can see the instructions, see what I'm doing. There is no mystery anymore. Now I need to figure out, so see how I started with fractions? My problem was given in a fraction subtraction question. I converted that to a integer takeaway subtraction question. I just need to convert that to fractions again. So now I have a general sentence here that you'll see repeat over and over and over. It takes how many pieces in general to fill a whole rectangle? It takes 1, 2, 3, 4, 12. It takes 12 pieces to fill a whole rectangle. We have 7, so we have left 7/12 of a rectangle. And we're done. I'll zoom out and leave that on the screen perhaps for a second. Ooh, so close. And I will be right back. All right, we're back. It was worth thinking about that one, I think. I had to do something anyway, but still, pause for dramatic effect, just to see how you feel. Now, this is just one way to write it, absolutely, but we're still noticing there is no making. How would you do this normally, right? One and one third, three quarters. Very extensive lines here. One and one third minus three quarters. You are not going to make this 4 over 3 and then common denominator over 12
Stephen,
and so on. That's not what we're doing, right? I don't want to see that. Yes, continue.
Stephen,
Yeah, yeah.
could you just quickly look inside the chat for a minute? There's just a bit of confusion over what's needed for the portfolio versus the test.
Okay, but we're talking about fractions now. We can talk about.
I know
Oh, I
it's just
see.
what
Fractions. Yeah,
you
yeah,
would
yeah,
write for
yeah.
fractions
Right.
on the test.
No, no, no. I've said before, portfolio assignment, you're doing it as if you are the little Timmy. So you'd have to look at those specific instructions. If it says draw a picture, draw a picture. If it says just find it, then you're free to just find it how you want. The test question is going to say specifically use a rectangle to explain how you can find the answer. And the worksheets might not emphasize that. So I can't remember exactly which worksheet. If what they say, you'd have to look at them and read the words. It depends what they ask. If they say nothing, do whatever you want. If they
They said
say specifically, then you're sort of restricted by that. And the test will certainly say that. Uh, and it, of course, depends on the grade, right? After you, this is, oh, where did they start arithmetic? Maybe three, probably not. Let's say grade four. Uh, you might start with this. Once you have that number sense and the fractions get bigger, then obviously we don't want to draw rectangles for any significant denominator past 11. So then I need to start asking, well, how do I make this more efficient? I get the number sense, I understand a fraction, but this is going to slow me down. Let's just get it done. Then we convert, of course. So a worksheet that you might look at might be a higher grade where we're just doing it because we're assuming we've built up from this already. So it depends. It depends on the grade the portfolio, the worksheet is, and all that. Does that answer all these questions? Where did I get the take away 9 pieces from? The instructions say to take away 3/4 of a whole rectangle, right? That's a standard default rectangle. It's got nothing to do with pink. When I do this portion, it's got nothing to do with the pink. Before I can actually physically remove pieces, I need to know how many pieces. And like we said yesterday, when I talk about a fraction, it's always in reference to something. In this case, it's in reference to a standard whole rectangle. Which means I have to figure out how many pieces does 3/4 of a whole refer to. Now, because I already have a rectangle I can look at, I just ignore the pink and see, oh, well, I have 4 rows here. That's exactly corresponding to a denominator of 4. 3/4 mean take 3 of the 4 pieces, rows in this case. 3 rows mean 9 pieces. So now I can go back and say what the subtraction instruction's actually saying is take 9 pink pieces away. And then obviously I have 7 left. And getting this 9 is a very good test of my number sense of fractions. Do I understand what the 3 and the 4 mean? The bottom, I was telling my 6-year-old, start with the bottom. It tells me how many equal pieces the whole is split into. 4. In this case, they're rows. The top number tells me how many of those pieces to take. 3 rows out of the 4. And because of the columns, in addition to that, on top of that, I get 9 little pieces. Any other questions on this subtraction problem? Now, you can put your own spin on this for sure, but I see far too many people writing far too little. You're not there to add words to your answer. It has to stand on your own. So look at it and ask yourself, is there any confusion if I were just giving this to someone? Can they follow this? Or do I need to be there to help explain it? If I need to be there, it's not enough. More words need to be added. But if it stands on its own and they can understand me whether I'm there or not, then it's enough. People use way too little in terms of words. Alrighty. I think that was the only main question, the 9 pieces. Feel free to interrupt. We don't have a lot of time. There is no time to sit back and like, oh no, I'm embarrassed. I don't want to say anything. This is not how we do fractions for ourselves. So it's weird and difficult perhaps, and that's okay. Alrighty, let's move on. Multiplication. Multiplication is a tricky little thing, unfortunately. The first version is where I have a proper fraction, like let's say 2/3, times, now it could be a mixed number here, it could be a proper fraction. Let's go a mixed number, let's say 1 1/4. Why not? That's the first kind I want to look at. Specifically here, first number is a proper fraction. Does everyone understand what I mean by proper fraction? No reaction. All right. So the key thing is that this multiplication is directly interchangeable with the word of. And that's a very convenient connection to use when I move forward. Because everyone, if I give you some pencils and I tell you, give me half of the pencils, you know what to do intuitively. Based on the understanding of the language, you know what to do. So the of word is already firmly in place to be used, and there's no confusion what that means. So we just have to connect that to our multiplication. And that means that this second number is what we have and what we start with. And the first one in the multiplication sign are the instructions of what to do to alter what we have and walk away with something. So we have, or we start with, the second number. Now draw it however you want. I am picturing Panorma's pizza. I have the whole first pizza. Now I know for a fact there are many people right now not perfectly happy with what I have been saying. It's your responsibility to interrupt me and ask. I cannot read your mind. But I guarantee you all these things are in the test. Then I have 1 1/4, so I need to split this into 4 equal pieces. They might not look equal, but they are. Ooh, wobbly. And I have one of those pieces because that's what the numerator tells me. All right. Perfect. 1 1/4. Now it's not perfectly set up for what continues, what I need to do next, but it's the starting point. Now the instructions say take a portion of what we have. Now that portion, that fraction, has thirds. So that means I need to split what I have, the pink, into 3 equal pieces. That's what the denominator tells me to do. So I'm going to go and split it into thirds. I could stop, but I'm just going to go all the way, realizing that if it's not pink, I don't actually have it. Just out of habit, I'll finish the whole rectangle. Now, they don't look quite the same, right? These pink pieces are smaller than these pink pieces. So I'm going to have to just make everything the same. So what I am saying after this applies to all the pink. Now all the pink little pieces are the same. So we have to, I don't know if take is the best word. I'm gonna use take. I'm just used to it. Take or get, maybe get, so we don't confuse it with take away. I get 2/3. Now this is different because there is something following this first fraction with the of concept. This 2/3 is in reference to that second number, not in reference to a whole rectangle. So I get 2/3 of what we have, which is pink. It's pink. What we have is pink. That means I need to split what I have into 3 equal pieces and take 2 of them. It's going to have to be rows. So I'm going to have to get 2 of the 3 rows. So I'm going to take that one, and not that one. But you can take any 2 of the 3. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of these pink pieces. That's what I can walk away with. That's what the instructions tell me to do. I follow the instructions. Notice again how we started with a fraction problem. We're changing it into an integer problem. All right. Back to black. Now I just need to figure out back to my fractions. What do these 10 pieces mean in terms of a fraction of a whole? So my standard sentence that I need, and notice I always write it out, it takes how many pieces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces, not necessarily pink, just pieces, to fill a whole rectangle. I have 10 of them. So we get 10/12 of a whole rectangle. And I can go up and say here 10/12. Notice how it's I don't know if I come across maybe as too much, but everything I say is super important. And I realize this. And I need you to listen to every word I'm saying. Not to sound pretentious or full of it, but I have refined this over many years. We are not doing the shortcut efficient multiplication. I see that, it shows me you don't understand what the question is asking, or what number sense we're building here. I can't give you the marks. We are not simplifying this fraction because that is not what the diagrams tell me to do. It's a separate issue simplifying a fraction. It's kind of pointless anyway. That people put way too much emphasis on simplifying fractions. It's not important. 10/12 is a perfectly good fraction. There's nothing wrong with it. So notice what we're doing. Notice what we're not doing. Very important. Let's zoom out and see the whole thing. Any thoughts on this first half of multiplication? There's a second half. The first half is there are two problems hiding behind multiplication, sort of. First one is where the first number is a proper fraction. Then the multiplication is purely that of concept. Any thoughts on that?
No, for me, it makes sense.
Good. Everyone needs to say that, though. Whether you say it internally, you need to say it. Not just for a test. We tend to focus so much on the test, right? Oh, I need to pass the test, pass the test. We have bigger goals here. We are trying to eventually teach a next generation. That's much more important than the test. The test is just to give us some structure. If you're sitting in front of little Timmy talking about fractions for the very first time, you better know what you're going to say. I did it literally coincidentally today. Literally, I kid you not, today was the first time a 6-year-old heard fractions. And I went in knowing exactly what I was doing. And it went perfectly fine. Some things, of course, are still going to be tricky. But if you're going to teach a concept, especially that first introduction sets the stage for anxiety or confidence. That first one, that first message you're sending is so crucial. And if you don't really know what you're going to do, then Timmy's going to pick up on that and it's going to fill him with anxiety. It's a fact. Studies have been done. Your math anxiety that could exist, whether you hide it as best you can, they know. They know something's up. And they have proved that kids pick up on it. So we need to fix it. Simple.
I think these diagrams have helped a lot because I'm really bad at just looking at it and knowing the answer, but
Oh,
having it
absolutely. Yeah.
put out like this, it helps a lot.
Honestly, I wouldn't even
They're explaining what we know.
I wouldn't attempt to explain it this way without a diagram. It's a key component. Absolutely. It's part
We
of
know
the
just because we know. Right?
Yeah, no, exactly.
But they don't.
They have no idea. It's so hard for me too to remember that they have no idea. They have never heard of a fraction. They have never heard of the word denominator. Well, I didn't even use that word. It's a scary word. They've never heard of this. So I have to forget that I'm so used to it and sort of rethink from the start. I will say I'm not sure if the answer key looks well. Actually, I'm pretty sure it doesn't look like this. There's been lots of iterations to get to this point. There are variations of how to write this. The column row split is much nicer, I think. But sometimes in the answer keys, you might see something else. Feel free to ask. Don't get confused by looking at an answer key that may be old. As soon as I update something one semester, I can't go and rewrite all the answer keys. I don't actually want to give those answer keys on the website, but it's there. So just understand when you look at them. Sorry?
Breaking it down like this puts it in
Oh,
a bit of perspective for me.
yeah, perspective is a big challenge here with our goal in mind of teaching this for the first time. There's a way to teach something for the first time, and then there's a way to ultimately do it. And with that number sense, if you look at the curriculum website, number sense, it's all over the place. It's just one of those key concepts. Because with it, you can get so far. if you have a number sense, especially when it comes to word problems. Number sense is the key to have confidence in a word problem, to understand how things translate into numbers and arithmetic required. It's and then the shortcut later on
And
comes
also
automatically.
trying to get past the idea of having to simplify, so we don't have to simplify right
I
now.
am never going to simplify, but
Okay.
because where this method doesn't ever require, there's no need. If you now forget what you know, forget everything. There is no simplification concept, right? Where is that a necessity in this problem? Does it prevent you from finding an answer? Does it prevent you from doing anything? No, simplifying does not exist here. It's one of those things. It's throughout. Go into high school and algebra, oh, they're obsessed with simplifying. And then I have to sort of overwrite that obsession when whatever first second year. Like it is not important. It depends on my needs. The standard rule is if I have an answer and I'm going to use that in a future calculation, let's suppose I take, for some reason, I can't imagine what, I take this 10/12 answer and I have a follow-up question where I need to use that in another calculation. Yes, cleaning this up and making it the nicest version possible will make my life easier in the future. Simplifying then has a purpose. But if this is my final answer and I'm done and I'm moving on to a brand new question, there is no need for simplification. It is honestly, it has been built up to give kids something to do, to keep them busy. Oh, just go simplify these things. It is not important unless there is a practical purpose to do something further with my answer. Then I want maybe the simplest fraction moving forward because working in future calculations with 10/12 versus 5/6, it's going to change the difficulty that I might encounter. Sure, there's a reason. Simplify away. But this is my final answer. I don't care. There's nothing. I'm not going to discriminate against 10/12s. There's nothing wrong with it. Simplifying is just overemphasized. Ugh, I can rant like this for hours. It is so silly. And it's because you get teachers that don't know why they're doing something. Oh, the book says simplify. I better do it. You can take that time and do it and spend it on more important things. Simplification is not one of them. Yeah, eventually, yes, in high school, you do need to know how to simplify algebraic uh, equations and expressions. Absolutely. But no, it doesn't need that much time. Anyway, second half of multiplication. Just to spice things up, why not have two faces of multiplication? Because why not? If I'm trying to connect this to, I guess, linguistic concept, then if my initial number is a mixed number, I'm going to make it 2 actually. Let's say 2 and a third times a quarter. So make it small. Why not? Now that multiplication sign, unfortunately, is not directly a single word. Unfortunately, it's just there's no way around it. Unfortunately, because remember yesterday I said this guy, this 2/3, is actually 2 plus a third. That I now apply to 1/4. Now that means I have to apply 2 to the second number. And again, I don't care what that second one is. It could be big, could be small, whatever. And I have to apply a fraction to that second number. Now, unfortunately, that means different things for different kinds of numbers. If I say 2 times something, and I say a third times something, note, I don't care what that something is. In this case, it's a fraction, I don't care. Those are intuitively different concepts. Unfortunately, I have tried. There is no single concept to handle them both with the same intuitive concept. It's just not going to happen. This one means of, no doubt. It works. It's perfect. I don't need any other words than of. But this one's not the same. I don't say two of a quarter. Maybe, but it's not as intuitive as this one. And I don't want to assume that's not really how we speak, right? If I had to ask 100 people, how do you translate this into words? Two times a quarter. Of is not gonna be the one that wins. It's not. Sure, times, and that means duplicated in some way, right? It's a duplication concept. If I had three of them, then I make copies or copies. Copy. Those words are going to come out. Yes, some people are going to say, oh, I could say two of a quarter. Is that really how we speak? Is that going to be how my 6-year-old speaks? Probably not. Probably not. But luckily, it's not a big deal because they already understand integer multiplication. 2 times something is repeated addition. It's repeated addition. So that concept, by the time I get to fractions, it's already in place. I don't need to really worry about this too much. I just need to emphasize that they're not the same. So there's a plus in between, which means putting together concept, which means I now have two instructions to do separately. And then, oh, that's an unfortunate line. And then at the end, I'll merge them together with a very simple addition concept. Now this one we haven't done the exact same one. Okay, so let me do the hard one maybe first. Let's go with the newer one. Now it's proper fraction of something. I start with the something. So I'm now going to do two things and merge them at the end. I have my second quantity, which is a quarter. And I want to see that. It's over there. I'll do it over here. Let's make it pink. There it is. I don't have much, but that's okay. Go back to black. Okay. I need to take. I'm used to the word take, but let's maybe say get. I get a portion of this. I get a third of pink. That means one of the three rows, because I've already used columns, I need to use rows to split this into three equal pieces. I take one of the three rows, maybe the top one, not the others. So that means I get one. That's unfortunate. It's not a lot. I'm not going to plural it. It is pink though. I get to walk away with one. Wonderful. Okay, that's fine. Now on the other side, at least I can double up what I have, so that's kind of nice. So I'm going to, in this case, double it, but maybe I'll just make copies. Come on. There we go. Let's maybe just say copies, because it's not always going to be doubling, right? Of the 1/4. So let's draw that. This is copy. So once. Twice. Whoops. No. Okay, so I'm going to take it once. That's a wobbly line. I apologize. And there it is. Get it once. Instructions say two of them. So repeated addition, right? So I'm going to take another one. or duplicate another one. Use whatever words you want. Whatever sounds the most intuitive to you. But the pieces aren't comparable, right? So for the reasons of merging these, just like when we did addition, I want them to be comparable, not pink, goof. So for that reason, I'm going to go horizontal so that all the pieces are comparable. I can only compare, merge, take away, whatever, pieces that are exactly the same size. So from this, ooh, that's a nice curly bracket. I get 6. I get 6 pink pieces. All right, progress. Ooh. So together we get 7 pink pieces. Now, same problem as always. I need to notice again how. Notice again how we started with fractions. We go to integers. Comfortable. My safe space by this time, hopefully. So we have to go back to fractions to finish the question. Standard sentence, why is it pink? No reason at all. It takes a certain number of these size pieces to fill up one standard whole rectangle. Because my answer is going to be a standalone fraction, which means it is in reference to a whole rectangle. How many of these pieces? Oh, I have a rectangle right here, right? I just ignore the pink for a second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It takes 12 pieces. So therefore, we get 7/12 of a whole, though you don't have to write that. Done. Zoom out. That's a lot of zooming. Zoom back. Sort of on one page. Not quite. But see how much number sense is going into this. So much. But it's pretty much all I need. I don't need any fancy tricks. Oh, I have to memorize to multiply the top and multiply the bottom. No, no, I do not. There is nothing like that happening here. Sure, my intuitive basic method, which this is going to fall apart if I have large numbers and complicated fractions. Like who wants to make rectangles and split them up into many slices? Sure, it's going to fall apart. But then naturally, I'm going to want something more efficient. The same thing happens in arithmetic, the exact same thing. That if you think about how kids start counting. If I say 7 plus 2, what is the very first way? They say, okay, 7 plus 1, 8, 7, and then plus another 1 is 9. They count them one by one by one. And then if I go 73 plus 35, am I really going to count 35 steps from 73? Of course not. The number's too big. That basic method is inefficient. I then naturally want something more efficient to get me to the answer. But I don't start with that. Never would I start with that. Yet, because teachers do not have a number sense of fractions, they run to the shortcut method because, oh, I hope little Timmy doesn't ask me anything because I don't really understand fractions either. And then, oh no, where does this anxiety come from in poor little Timmy? We've created it by not equipping ourselves with the number sense. So I apologize if I come off as a little aggressive, but this is what's happening in school, and it is not okay. And it changes with us. Any thoughts on the second half of multiplication? There is no way to merge these. It's just not going to happen. Multiplication has two faces, sort of two, and because I'm working intuitively. If I'm going to the fast multiplication, now it doesn't matter, right? I convert the first one to an improper fraction if I need to. Change this guy to an improper fraction. And I do the same thing. There is no, mathematically speaking, there is no distinction between multiplications. It's all the same thing. But if I am going to build up a number sense, I require some intuitive concepts, and then unfortunately, certain situations require slight variations in my intuitive understanding. So it makes
Steven?
sense. It's unfortunate. Yes.
How do we know that the 2 1/3 is not what we have, the quarter is what we have?
That really comes from the first kind of multiplication. If I make that first number a proper fraction, because it's the intuitively easier one with fractions. If I ask little Timmy, here are 10 pencils. Your instructions, give me half the pencils, half of the pencils. What is he going to do? He's going to immediately apply that instruction to the 10 that he has. And that's the second number, half of 10. He's going to take a portion of the 10. So intuitively, if I think of the quantity that I'm starting that problem with, that quantity is captured in the second number based on the sentence.
Basically, quarter is quarter of 2/3. Or sorry, 2 1/3. Correct?
Are we looking at the same screen? This one is 2/3
Oh, right.
of 1 1/4.
Right.
I'm not reading backwards. I'm still reading left to right. Everything I'm doing is in a way left to right. It's still a sentence that I'm reading. It's just a number sentence. So because of that very simple first intuitive concept, just use a half. Everyone understands what to do with a half. That tells me the corresponding multiplication, 1/2 times 10, implies that 10 is the quantity I have. The half is the instruction. The 10 is what I start with. I have 10 pencils. So the second number in multiplication involving fractions, actually involving anything, is what I have. I can convert that. Now with integers, if I say 2 times 3, I can spin that two ways because it doesn't get me into trouble. I can say I have 3 things and I double it, or I can flip it around. But in the fraction case, the flipping is not intuitive, like 2 and a 3, flipping 2 and a 3 could be. Even then, I just don't even bother flipping it. There's no benefit, ever. Once they get to memorizing their multiplication, and I want to flip it around, so maybe they like the first number being smaller, at that stage it doesn't even matter anymore because they've already stepped beyond intuition. When I build up the intuitive number sense, I'm not going to flip 2 times 3. There's no benefit. They can see 3 times 2 is different intuitively, and then later on realize, oh, they're both 6. Why? Sure, then we can talk about it. There's no need to think about that. So in both cases, for all multiplication, the second number is what I have.
Okay.
Now, mathematically, of course, you can flip those around and you'll get to the same answer. But the intuitive understanding of what that sentence tells me to do, what that instructions are, is very different instructions. Will they lead to the same answer? Yes. But it's not intuitively obvious why. And little Timmy doesn't have any, he doesn't know any multiplication properties or anything like that, right? He just has his intuition. So that number sentence has to be translated into words which he already understands because he has his language concepts, that then tells him what to do. Mathematically, he has zero knowledge and understanding of the multiplication operation. So we need to put it in a language, put it in words that he understands. So I'm reading left to right. I'm not changing. If he reads a sentence in a book, you can't just swap words. So it's not going to feel natural for him to do it now. And later on, we can show that, oh, this is actually a slightly different language with different rules. Fine. But right now, I want to read it as a sentence and make it as much intuitive sense as possible. Yes, it's
Okay,
quite
thank
a
you.
thing. It is quite a thing. Don't ever feel like, oh, it's just me. I'm not getting this. I don't want to say anything. Everyone else gets it and I don't. I guarantee you that's not happening. In no way are you the only one. Definitely not. I will put. I don't have any money, but if I had money, I would put everything on it because that's just not the
So
case.
with multiplication, you presented two methods. Is
Yes.
the second method utilized when the mixed number is in the front and the other
No,
one when it's in the back?
it doesn't matter what that second number is. It could be a quarter. It could be 2 1/4. It could be 7. It's completely irrelevant what this guy is. Doesn't change my concept. It's all about the look of the first number.
Okay.
If the first number has two options, it's either a proper fraction with no whole portion, or it has a whole portion and it's a mixed number. Those are my only two options.
Do you mind scrolling down on that screen just a little bit?
Sure. I have no other options. So based on which situation I'm in, that determines how I handle everything. The second number, I might have a lot, I might have a little. It doesn't matter how I handle it. I'm still taking from it. So it doesn't matter at all. It's all about the first number in multiplication. Luckily in both. And then I just have to think, okay, it's a proper fraction. So then intuitively it means take a portion of that second quantity. Or it's a mixed number. Oh, it's actually telling me to do two things and merge them at the end. In truth, a mixed number needs to stay on the intuitive side. It's not an efficient way of. It's not an efficient number representation, if I can say it like that, because it has a whole portion and a fraction portion, and those two things don't gel. Which is why when we do the fast multiplication, I change it. I will never use mixed numbers in actual calculations. They're there for intuitive purposes. We change them to proper fractions because then I at least have one thing to focus on. But now we are on the intuitive side, which means the whole and the fraction portion needs to be handled separately in some way. Luckily, only in the multiplication way. The others don't have an intuitive distinction, luckily. Good times and division is still to come. Man, it just gets better. I love it. I love it. Now, there's good news and bad news with division. Good news, there's only one interpretation, thank goodness. So there's no split or anything like multiplication had. It is seriously raining. Wow. Sorry, focus. Okay. The bad news is it's not the same as multiplication in any way. Now remember, I don't know any mathematical properties and shortcuts and the actual very strong connection between division and multiplication. I know nothing. I'm on the intuitive side, blissfully ignorant. So I'm going to set something up. Let's not make it too hard. Let's say 1 1/4 divided by 2/3. That's a nice standard one. All right. What is my intuitive understanding of division? It comes in two versions. It's not that you can't proceed with either one of them, but for me personally, one certainly feels easier than the other. Feel free to challenge me on that. It could just be my personal bias. If I look at, actually, I shouldn't do it on this page. We're going to continue here. Let's make a new page. If I look at, I'm pretty sure I used that one in the video as well, 100 divided by 5. I know the answer. It's kind of irrelevant, but sure, I'll finish it. And you were to, and I asked you, make up a word problem for which 100 divided by 5 is the calculation, the appropriate calculation. Now you can say one of two things. You can say, okay, I have 100 people. I have 100 people, and I make groups of 5. Let's suppose 5 people have red shirts, 5 people have blue shirts, so on and so on. How many groups? 100 divided by 5 is exactly the intuitive understanding of division. It's in your grade 3 books. It's going to happen all the time. Okay. But when it comes to integer division, there is another one. I still have 100 people, and I split them into 5 groups. How many in each, yeah, it looks like a K, it's an H, group? Is everyone happy that there are two ways, two word problems that would give me 100 divided by 5 as the answer, essentially? Now, if this is shaky in any way, then fractions are going to be very bad times, because we're going to rely on our integer concepts and build fractions on top of that. We're building a very big building, and if the foundation is shaky, it's just a matter of time. Everything's going to fall apart, and I'm going to be really nervous if I walk around in that building. Okay. Now, personal choice is this one. I'm quite sure you can do the other one, but why? There's absolutely zero need for me to jump back and forth between these. Pick one and go with it. And for me, when it comes to fractions, understanding the division concept feels easier if I look at it like the left one. So that means the first number is the quantity we have. The second number is my group size. And I'm asking, how many times does that group fit in to what I have? Okay. Same operation, same intuitive concept. So I have, and there was never any memorization. If you ask this question, okay, maybe not with 105, maybe a little later in grade 3, maybe. Pick easy numbers. Then, not everyone, most little Timmies will understand what you're asking once they have the essence of division down. That is the intuitive definition of division to a large degree. Seeing a question in the chat, they're the same thing. It's the same thing. I copied some questions, not copied, right? I borrowed some questions from certain books, and in those books they called it part of a whole concept. That's our rectangle concept. Same thing, same thing. We only have one intuitive way. There's no, they can call it different words, same thing. Okay, so I have, excuse me, I get a little emotional when it comes to division. It's so beautiful. I have 1 1/4. It's not nothing, but it's not much. So let's see it. I have the whole first one. Good job. And we saw we don't always have to color it, split it up. Like in addition, I would never split it up. But second one, I don't have a lot. So I'm gonna have, oh, that is wobbly, come on. I'm gonna have to split it up. Wow, I am on fire today. Get a straight line there. Oh, so close. I have one of those 4 pieces. Okay, good. I have something to work with. Good job. Okay. Now I read the instructions. Luckily, it's always going to be the same. I have to look at my group size and fit that into what I have. So my group size, I'll call it, is 2/3. That never stands alone. It's 2/3 of a whole rectangle. There's nothing else after this. It's not applied to anything other than a standard template whole rectangle. So I have to translate this to how many pieces are in this group that I need to work with. In order to do that, I split everything into, whoa, that is not horizontal, into 3 equal pieces. That means everything. And to have all the pieces comparable, I'm going to have to split my first rectangle into 4 columns as well. Didn't know if I should. Yeah, I kind of should. Okay, now this 2/3 refers to a whole rectangle, which means I can use a whole rectangle wherever I see it, but there is no reference to pink. This is not connected to pink in any way right now. 2/3 of a whole rectangle, take a rectangle, take 2 of the 3 rows, 1, 2, 3, 4, 5, 6, 7, 8. 8 pieces. Those pieces aren't pink, they are just pieces in the rectangle. If you are unable to ignore the color, draw a rectangle that looks exactly like this, somewhere else with no pink, count 2 of the 3 rows, you'll get 8. I need to know, when is the pink important, when is the pink not important. Now the pink is important again. So we need to ask ourselves, how many times can a group of 8, that's an ugly 8, I apologize, 8 pieces fit into what we have? Notice how many words I am writing. Yet in a test, no one writes any words and I have to guess. Use words. That's how we communicate. All right. So that's my question. Well, let's do it. Let's start fitting it in. I'm going to use blue because I want to. So, oh, groups of 8. Oh, that's a lot. 1, 2, 3, 4, 5, 6, 7, 8. So this would be a group of 8, right? It doesn't matter how I connect them. I just want 1, 2, 3, 4, 5, 6, 7, 8. So that is once I can fit in a group of 8. Do I have any hope of doing it again? 1, 2, 3, 4, 5, 6, 7. No. So close. So look at my full sentences. We can fit it in one time with 7 pieces that are pink, because we're only fitting it into what we have left over. See how we took the fraction calculation, the fraction problem, transferred it to a integer problem. Now we're not going to bother calling that 7 a remainder or anything like that. There's no remainder here. There's no need for it. We need to now figure out this 7 that is left over. How much of a rectangle? No, that's not right. What is the fraction that is associated with that 7 that's left over? That 7 is not going to be compared to a whole rectangle, because that's not what we're doing. We are trying to fit in groups of 8 into the pink. And I have 7 left where I need 8. So how many of my group can fit in 7/8 of it? So let's just say our answer here is therefore 1 and 7/8. You can say it in a variety of ways. You can say I can fit in a group of 8 1 and 7/8 of a time. Or I can say my group of 8 fits into the pink once, and then 7/8 of a group can fit in what's left. It's all the same thing, really. What bothers people, and I don't really want to say it, but at the risk of creating confusion, that this is the only answer that is not in reference to a whole rectangle in the same way. It's in reference to a number of times I can do the instruction, which is very different. And the more you scratch at that, the more weird it gets. So maybe you want to, maybe you don't. Division's a little different. As we've seen in past chapters where we often leave out division and give it its own part 3. It's a little different, but it is what it is. So once I get the hang of division and I understand why I do what I do because of the intuitive understanding of division, which is how I learn it, grade 3. Maybe not with 100, but still, I could, yeah. I prefer the left one because then I can draw these blue ones fitting in groups. But I'm sure you could do it with the right one too. I just see no benefit in flipping back and forth between them. I don't see how that's going to help me avoid confusion in any way. I don't like the right one, but it could be my personal issue. It just doesn't feel intuitive to me. And this method is all about promoting intuitive number sense. So feel free to put your own spin on it, but I'm aiming for the path of least confusion here. Let's see what the chat says. This really makes sense. Great, I'm glad. But what should we do when the divisor is bigger than the dividend? It does not matter at all. That's more good news. It doesn't matter. It might intuitively feel strange, but it doesn't matter in how I handle it. You might be tempted to think that, yes, it flips because division is in many ways the opposite of multiplication. So I'm now having my second number in a way. No, not having. I'm having the first number where multiplication had the second number. So if that other number is bigger, then I should do something else like I did in multiplication. No, not at all. None of that is true. None of that is true. Let's exaggerate it. 1/5 divided by, there's no benefit in making this too big, but sure, let's make it 1 3/4. Let's go crazy. Why not? I think I need to zoom in more. Yeah. Let's go crazy. Okay. Nothing has changed. Nothing has changed. Which number do I have? Think of the... Oh, where is it now? This one. Same division sentence. The first number is what I have.
1/5.
Yeah, it's the first one. Doesn't matter how small, how big. I have 1/5. Sadly, it's not a lot, but it is what it is. So let's visualize it. Fifths somewhere over here. I pretend they're equal perfectly. Yeah, it's not bad. I have 1/5. Oh, it's so little. Ah, that's okay. We work with what we have. Okay. Nothing has changed. I have a group size. Nope. There. Group size is 1 3/4. I'll say here of a whole rectangle. It's in reference to a whole rectangle, but I'll maybe do it like that. Because it's a mixed number, of course, it's referencing a couple of rectangles. So I only see one rectangle because I only had to draw one rectangle. Now, based on the group size, I need to see more rectangles. They're never going to be pink. I just need to see them. Nope, that's not a good fifth split. A little over here, perhaps. Oh, wobbly. Get your head in the game. Wow, that is terrible. What am I doing wrong? That was too many, wasn't it? Seriously? Trying to do it quickly. Wow. You know, it's deceptively hard when you can't see your hand. You don't know the angle it's at. Whoa, this is embarrassing. Okay, straight line tool it is. I have very limited drawing skills. I'm not going to color them pink or anything. I just want to see them because this second fraction extends over one rectangle. Fine. So I can't quite see the pieces because the denominators aren't the same. So I'm going to have to go in 4 equal pieces across so that everything is comparable. So 1 3/4, that's a lot. That's a lot. That means take all of the first rectangle and 3 of the 4 rows in the second one. So that's 1, 2, 3, 4, 5, 6, 7 rows of 5. So my group size is 35 of these little pieces. Okay, so that's a lot. And I only have 4 pink ones. So obviously I can't even fit this in once, but I'll write it down. We can fit the groups of 35 into what we have 0 times. That was an M with 4 pinkies left over. All right. It just feels strange. Nothing has actually changed.
Sorry, can you go over where you got the 35 from? I missed that.
1 3/4, all of the first rectangle, 3 of the 4 rows in the second.
Oh, okay, thank you.
So I can fit it in 0 times, 4 left over. So how much of my group can I fit? 4 35s. 4 35s of a group I can fit, or 4 35s of a time. That sounds weird, but 4 35ths of a time I can fit in my group, if you want to say it like that. Nothing has changed. So that's more good news. Good news. It does feel a little strange, but I handle it exactly the same way. Intuitively, it does feel better if I can at least fit it in a couple of times. I can do something. The sizes are so uh, different that there's not much I can do. But nonetheless, good stuff. Well, that session went by very fast, like I knew it would. There's a lot to do. But luckily, after the arithmetic, talking about decimals, talking about rounding, there's not much. Not much there in comparison to this. It's just a reminder. Do you know how to round? Are you aware of these things? And then when we go over to converting a decimal, sorry, converting a fraction to a decimal, other way around, sorry, decimal to a fraction, then we're dipping our toes into the concept of a variable and an equation and some algebra, and we're heading through percentages into full-on variables and equations. So it's really all aiming for the same topic. We still have Thursday and Friday for that, so not too bad, not too bad. But this is definitely the heart of the fraction issue, is this arithmetic and the rectangles for sure. All right. Hopefully that was informative. Remember, all these things are on YouTube. Watch them again if you need to. Talk to each other. No one is using the chat in any way. If you have a problem with a problem or you're not sure, post it. Put it in the chat. I'll see it. Someone else might see it. Instead of private messaging me, maybe someone else like, oh, that's a problem. I couldn't find it either. Or someone, oh, I got the same answer. That's what Discord is for, to have a community supporting each other. But you have to use it to get the benefit. All right, until later then.